Maybe your car wasn't in the driveway, so you might have picked up the phone and almost called the police, or were kind of freaked out or panicked a little because you thought like this was supposed to be a live video feed of my house. And it turns out this is actually the #1 question on the FAQ. Is they explain why Google Earth isn't a real-time video feed of my house. And it's interesting because they never said that Google Earth was real-time. It's not called live Google Earth. It's not, nowhere in the entire website does it say that these are live pictures, but people just kind of expected it. So they, people who didn't really know the finer points of satellite communication thought that there was some satellite sitting up there just taking a constant video feed, and that they were piping that down to your computers. Yeah, so it turns out that there's really something fundamental about this, that they just kind of expected this to be real time. One second, I fix technical difficulties. All right, much better. Okay, so it turns out there's something fundamental about this, that they thought that this was just going to happen. The users downloaded the application, and it's what they expected right off the bat. There was no contract, there was nothing, there's no user terms of agreement that they accepted that said, yes, we're going to provide you a live video feed of your house. People just expected this. The other question that I like to ask our users is, how long do we have to engage your user base? And this is a really, another really hard problem to solve. Is a lot of people think that I'm just going to put my website up there, I'm going to put all my images up there, I'm going to put my how-to video on the homepage, and users are going to start walking through the door. There's been a lot of studies about this. People like Google have done studies on this. People like Microsoft and Bing and Yahoo, and everyone is trying to figure out like, how long do we have before our users leave the page? For those of you who have been in web development long enough, you'll know that the answer is about a minute. So by the time the user hits your site, you have about a minute to actually do something interesting before they move on. This is usually new users who are coming in the pipeline. This is the amount of time. This is all you got. So when you're building a website or a web page or an application, if you're not entertaining them in 1 minute, they're going to leave. They're going to go somewhere else and try and find something interesting. So this is where the idea of the WebRTC Data Channel comes in. Is on the web, and especially in JavaScript, we have the need for higher performance and lower latency connections in the browser. So we need ways to basically get that data or that information to your browser much faster than we do today. And the way this works is that it goes through a WebRTC peer connection. And what that does is make a peer connection between two browsers. So if I'm sitting here on my phone and my laptop's sitting over there, my phone can make a direct connection with my laptop, and now they can share and exchange data between the two of them. And that's pretty much all it is that the black box is a little data packet. It's actually coming from one browser and going directly to the other. There's no servers in between, depending on how you set it up, but there's no network to traverse. It just goes the shortest distance. And this gives us a lot of capabilities. So the first one is flexible data types. For those that program in JavaScript, it supports array buffers, blobs, and strings. For those that don't, it basically supports an array of strings, characters, or binary types in JavaScript. So it's really arbitrary what you're sending. The data can be anything. It doesn't have to be a file. It doesn't have to be a video stream. It doesn't have to be an audio stream. The data can be anything that you're looking to send. And the other great thing that we have is that it works in 2 modes. So when you're sending data between these 2 browsers, you can actually set it into a reliable mode, which gives you, much like WebSockets today or RESTful APIs, where you have a guaranteed transmission of all the data, but you have the overhead of sending acknowledgement packets back to say, yes, I got this. I got this packet of data. And the real power, though, comes from the unreliable mode. So this works a lot like UDP today, where if you set it in unreliable mode, it's just going to send data as fast as it can. So this is where the real high performance, low latency connection comes from, is that you can send data as fast as possible, and you really don't, there's no really guarantees on it, but it's just as fast as it possibly can. So if you think of like multiplayer games today, people running around a world and sending position updates between people, this is the technology that they're using today, is this UDP, low latency, no reliability technology. So there's a little bit demo of this. I have to be over here to do that. But I'll show you the kind of simplicity of how this works. All right, don't fail me now. There we go. All right, so what this is doing here is actually making a connection to itself. So this browser is acting like the other browser on the other end, and it's actually making a peer connection with itself. So all the data that I'm putting in the text box there is actually being sent across the wire, and it's figuring out, okay, what's the fastest way to get back to the browser that I just came from. And if you saw, this is over I'm on a 3G network on my hotspot, and those packets of data were coming back instantly. So it's not having to go to a server, figure out a bunch of stuff, and then network and find itself all the way back to that computer. It goes out a little bit, says, oh, I just have to turn around and come back, and comes directly back to that computer. So it's really, really, really fast. And the API for this is actually really simple. So this is actually a majority of the JavaScript that it takes to set this up. There's no subclasses or objects or anything crazy that you have to set up. It starts by making an RTC peer connection. This is exactly what you would do today if you're using the audio and video capabilities of WebRTC. And then all you do is call peer connection, create data channel, and this will give you a data channel object back that you can send and receive data. You also provide a label, which distinguishes your data channel versus others that have been created on the same object. And then the options bracket afterwards is where you can pass your reliable true or false. So this is where you can set it into that high or low latency, no reliability mode. It gives you a lot of events that come back on the data channel. So there's an error event that comes back when something's wrong with the connection. You also get an on message. So this is if someone else is sending you a packet of data. This is how you would get the, the messages from the other side. And then all you have to do to send a packet of data is called datachannel.send, pass in what you want, and the browser takes care of the rest. So this is, if you've ever played with WebSockets and JavaScript, this is really overly simplified to try and make it as easy as possible to get up and running. And that's pretty much all it takes to create a peer connection. So we were talking about doing, setting up TCP sockets and opening up and binding a socket on another computer. All of this stuff has basically been abstracted and made it as simple and as easy as possible to interact with other browsers. And this is the kind of stuff that if you're writing this in C or Java or something else, you might use 7 different frameworks, 5 different libraries, and 4 different classes to try and set all this up. And in JavaScript, it's just maybe 10 lines of code. Question? Right. So that's the great thing about using browsers in JavaScript is that this is all standardized. So there's a specification that all the browsers have basically agreed that we're going to include this technology out of the box. So there's nothing, the user is never going to have to install anything. Much like Flash, if you use Flash or Java, you have to kind of accept an agreement and you have to install some piece of software before you get up and running. With this works right out of the box. So if you guys are using Chrome, if anyone in here is using Chrome, you have WebRTC on your computer already. If you're using Firefox, you have it on your computer already as well. There's no install or download or anything else. So this can be run in any JavaScript file. So if you're building an HTML application, you have a JavaScript file hosted somewhere, maybe on Akamai, and that gets downloaded by the browser when you load the web page. Any other question?
So in that code, I don't see how you specify what the specification of the other side of the connection is.
So when you're making a peer connection, there's actually a whole bunch of code that goes in between here that is not very specific to the data channel, so I've kind of left that part out. But there's a whole signaling mechanism, which I'll do more detail down the road a little bit. I have a better slide for that. But it's basically a protocol that they've developed where you signal the other user and you give them a session description which tells you how to connect with the other user. But I can go to that a little bit more later. So the big question on everyone's minds is always, is it ready? Is this ready for today? The great news is that Chrome and Firefox, it works not only on the desktops, but also on Android. So if you're using Chrome or Firefox OS or browser on an Android phone, you can actually make a peer connection with a computer or even another phone. And the interoperability between the two is, there's still a few kinks to work out, but it's almost there. So you can actually make a peer connection data channel between a Firefox browser and a Chrome browser. So it's something that's been already tested, already implemented, and already ready to be standardized today. The bad news is IE and Safari are still unknown. We're not really quite sure when Internet Explorer is going to implement it. And Safari has also been quite quiet about when that support is going to come in these browsers as well. Opera is actually working in Opera for Developers, which is the kind of developer testing version of the latest and greatest stuff. So that's actually coming down the pipeline probably in the next few months. A lot of people are also worried about security. The great thing is it uses DTLS for security from end to end. So it's mandatory that your data connection is always encrypted. What I would say about this is that speed is always a bigger concern. So it's meant to be a high performance data channel more than it is to be a secure connection. So if you're trying to pass credit card data, God forbid, through a peer connection, probably shouldn't do that. You probably should either double encrypt it or use your own encryption algorithm to try and secure that a little bit more. But the biggest threat to your security is other users sending malicious data. So a lot of people call this kind of like the Napster of the web. Now we can send data back and forth between browsers, but you don't know who that browser really quite is. It can be spoofed. You have to really make sure that that other user is not a malicious user and that they're not going to send something threatening to your browser. So you want to make sure you're including code in there that's always checking the data that's coming from the other side, making sure there's no malicious data. You're not running any code that people are sending from a data connection. There's also a few other considerations when using the data channel. A lot of people think that this is the end of servers, that now since browsers can talk to each other, why would we ever need a server ever again? But don't freak out, because I really think you need more servers to do this implementation for things like presence, so figuring out when is my user online, when is my user offline. Also analytics, so you actually don't have any visibility into any of the data that's being sent through a data channel. So one of the considerations when using this is that you want to try and take the important information that you're sending and relay that off to another server as well. So not only am I pushing that through the data channel, but I'm also replicating that and maybe sending it to Google Analytics or sending that through some other service. You also need a system to manage user IDs. So figuring out who's who and what's their username, what's their user ID, where are they at. You still need a whole level of cloud computing systems to be able to figure that out. Also storage, multicasting, signaling, storage for if the data channel isn't storing any data on the client computer, so you need to figure out how do I get important user configuration data to my users. Multicasting is also another interesting topic. So since this is a peer-to-peer connection, if I wanted to send data to 5 other users, I would have to make a peer-to-peer connection with each of those users. And it turns out that once you start getting to about 10 or 15 or 20 people, this model starts to break down because you're opening up a socket connection with all of those users and they're doing the same thing back. So you can see it starts to kind of multiply exponentially. Question?
One browser wants to send to another, right? Is there a condition control on the other side? Because, for example, if I don't want people to send me large amount of data, is there any control in this kind of mechanism, say I can stop or filter out some of the data?
Yeah, so JavaScript's always run in a sandbox. So there is a level of security, and security is definitely really important for the browser vendors. But there's no like user permissions that will ask the user, hey, do you want to make a connection? Much like, if you open up a web page today, they can send off any analytics data that they want about your visit to that web page. They can track what you're doing. If you click on a button, they can send that to Google Analytics. Same thing for the data channel. So if they want to make a peer-to-peer connection under the hood and not really tell you about it, it's definitely something that's possible right now. So you always want to be visible with your users that, hey, I am connecting you to another peer and sending that data. Yeah, so the multicasting problem, definitely something there's a lot of vendors out there right now that are figuring out these issues and how do I send a peer-to-peer data connection between 100 different users. So there's definitely a need for some server that kind of sits in the middle to figure out the relaying of that. And then signaling is the last one, which is the question that we just had asked was, how do I find the other user and tell them about my browser so that they can actually make a connection with me? And the other big the consideration that I'd give to people implementing the data channel is that this means new levels of data. So this is actually something that we ran into when we were prototyping on top of it was we started to try and send files. And you can do this on the data channel. You can take a file, break it down, and send it directly through a peer connection. So basically the Napster LimeWire of the web, which is great. But we started to send bigger and bigger files. We're like, oh, well, let's send a 1 gigabyte zip file. Let's send a 2 gigabyte zip file. And then we started to get to 4 gigabytes. And we're like, wow, I don't even think JavaScript can handle a 4 gigabyte file in memory in the browser. So we started having to figure out, okay, how do we chunk data in a certain way? How do we send 4 gigabytes of data across the wire? It's something that's not commonly done today on web pages. So we have to start thinking about how do we solve these problems that are going to be coming up in the near future. And the other big thing is, this is where I can talk about the signaling a little bit more. So to actually make a peer connection, right now, you have to have some form of signaling. So there's some way where out of bounds of the peer connection, you have to connect the users to each other. So if two users open up their browser, there has to be some server that says, okay, user A, this is how you find user B, and okay, user B, this is how you find user A. And right now, it's kind of something that a lot of companies have sprung up and been trying to solve this issue, mainly because it's a thing that you have to do to even get started with WebRTC. So my answer to this is you really want to, there's a lot of technical stuff in here already, and you really want to utilize some cloud system or some, there's a bunch of cloud companies out there already that are making it much, much easier to use the WebRTC peer connection. And in my company, PubNub, we've been trying to make it as easy as possible to get started with the WebRTC Data Channel. So right out of the box, instead of having to set up a server, you can actually use a cloud service to just make that connection for you, and you don't even have to worry much about how do I make that connection or how do I send data between the two. You can just utilize the cloud service to do that. So the question on everyone's mind is, what can we do with the data channel? Why is this all important? And the picture is in no way related. But it's always kind of a joke that a lot of people say is, oh, well, we can make Skynet, we can make Terminators. And this is interesting because it kind of opens up this new thing where I can make a program that is smart enough to connect to other browsers and start being sentient, doing things on its own. And it's never going to touch a server other than to do the signaling part. But it's never going to send its data to a server that you can look and inspect. It's completely on its own to make its own out-of-bounds connection. The one great thing that I'm really excited about is better device-to-device experience. So a lot of people think of WebRTC as now I can make a call between my phone and my mom's phone. And I really think of WebRTC as, well, it's not just people, but it's also devices. So why can't my device, much like I'm sitting here controlling my slides with my phone, why can't I do that with WebRTC? My phone can make a direct connection with that computer, and now it can tell it exactly when it wants to go to the next slide. And this is stuff that we're kind of starting to see spring up, is the whole Internet of Things idea, where if we have all these things that are connected to the internet, how do they all talk to each other? And the data channel is a great way to really start inspecting that and start doing really interesting stuff. For instance, the Chromecast that just recently got released is a device by Google Chrome, plugs into your HDMI port, and now you can stream things using your Android phone. So if I have Netflix on my phone, I go and find a video that I want to play, and I tell my Chromecast to play it, and it takes care of the rest. So these are the things that you can be doing today with the WebRTC Data Channel. It also opens up a lot of faster applications for data sharing. So multiplayer gaming is the big one. We can now make games that all my players are now talking together using a UDP, like really performant, really high speed, and also low latency connection. And this is something that we really haven't seen in browsers lately. A lot of this technology has been kind of hidden on the C++ layers, the C layers. Now this is being opened up to JavaScript developers. The other big thing is file sharing. So if you want to share a file with someone, you can make a peer connection, and now you can pipe them data directly. So you can share images, documents, files. And this opens up, a whole new class of applications for that. And then there's a lot of really side interesting things, so like remote control, like I said, controlling the slides from my phone, controlling an RC car with my phone or a tablet. Second screens, so if I'm watching a video, my TV can actually be sending me data on my phone telling me about the shows that I'm watching and interesting things about that. I don't have to be connected to the internet, I just have to be in a local network. And also content delivery. So this is a really interesting one that kind of sprouted up recently was if I'm opening up a web page on my computer and I'm sitting next to someone, say I'm opening up Facebook and they've already been to Facebook, so they have all the files that I need to render the Facebook homepage, why don't I just go and get those files from him instead of trying to find some Facebook server that's out in California or Virginia somewhere in a data center. Taking the shortest path to actually get those files off their computer, making my page load much faster than it would if I went and got those files from another state. So there's a lot of great examples of this already. Unfortunately, I can't control the mouse with my phone, so I'll have to kind of be up here showing some of this off. One of the things I want to show is the file sharing part of WebRTC. Let's see. So this is something that we worked on at PubNub. This will be interesting over a hotspot connection. So the idea is that two users can log into this website and they can start sharing, and they'll be able to see each other logged on, and then now they can choose a file to share with each other. So let's see, I think this is the one. There we go. All right, great file. So now I can open that up for sharing, and I can call get. This might take a little bit longer than usual. But what that's doing is it's opening up a connection between those two tabs. It took 6.6 seconds. Usually it takes about a second or 2 seconds. And that's about the size of a wallpaper image. And the amazing thing is that I'm not paying for any bandwidth. So I'm not setting up a CDN, uploading this, and then having someone download it. It's going directly between those two tabs there. So we haven't paid anything. We haven't paid a cent for bandwidth, a cent for connections or anything. That entire file was transferred completely on the user's network. There's also a few other links up here. So these are really great things to check out if you're more interested in WebRTC. One of them is Banana Bread, and this is basically a WebGL demo. So this is like a 3D game running in the browser. And Mozilla took that and actually made it a multiplayer game using the data channel. So it's really cool technology. I think they got like 5 people playing in the same room at the same time, all against each other. So really great example of how you can utilize this technology. The other one is Peer CDN. So this is a really good example for the peer-to-peer downloading kind of thing, where if I'm on Facebook and the person next to me has been there, I can actually download the scripts off their page. This is actually the framework to do it out of the box. So they've built this entire framework that you include on your page, and it'll teach you how to set it up and how to get this enabled in your browser today.
The implication of that, if the person next to me is on a website, I can basically download the pages that they watch the video.
Potentially, I think it's a little more on the CDN side, where it's kind of on the files that aren't vital to your experience. So there's going to be the HTML that you download, which is customized for you based on a server. So if you're logged in, it'll say, you know, hey Dan, thanks for being logged in. Up in the top right corner, it might show some news stories about what I'm interested in. So that'll be personalized for me. But what this is saying is there's all these style information, images, and maybe JavaScript files that are common for everyone. So everyone is getting the same exact file, and it's coming from some server, you know, out on the network somewhere. And it's just saying, since all those files are going to be the same no matter what, why don't we just go to the person next to us who has that file already? The one comment I want to make is real-time means more engagement for your users. So this is the thing, you know, this is how you leapfrog your competitors today, is you have a minute to entertain your customers, to entertain your users, your application users, end users, whoever it may be. You know, you have a minute, 2 minutes, maybe 5 minutes to entertain them in some way, to engage with them in some way. And, you know, that's not only going to make them want to come back if they're seeing a more interactive experience, but it's going to make them want to spend more money on your web page or on your application that you're developing. So, you know, we're really big proponents of real time. We think that it's really going to be, you know, it's going to be how websites are done in the future. So, you know, gone are the days of loading up a web page and seeing exactly what I sent you and then nothing changing for the next 5 minutes. You know, maybe it'll load up a page and then it'll ask me some questions about what I'm interested in, and then it'll provide me, you know, here's a, a personalized view of what we think you'll be interested in. Or maybe it's an interactive code tutorial where I'm coding and someone's watching me, you know, code and install your SDK to see, you know, what's my level of ability. Am I interested in buying my framework or my cloud service? So, you know, I really think that web developers in general, and just, you know, in general application developers, should start thinking in real time and less statically. And it's really, the data channel is opening up a new age of computing. So it's kind of changing the way we think about this stuff. You know, no longer am I just connecting to 1 server, 2 servers, 3 servers and getting my website, but I can connect to more computers. I can connect to the people next to me. I can connect to my phone. I can, you know, all of these things can now, you know, the whole Internet of Things idea where everything can now interact with each other and share data with each other, and create a more dynamic and engaging user experience. So that's it. There's information to find me on Twitter and my websites. Also, the URL for all these slides. So all these slides are HTML, JavaScript. You can fire it up in the browser. And then if you want to learn more about the WebRTC in general, PubNub has a great framework that I worked on and a few other people worked on to bring WebRTC and make it a lot easier for developers to do this today. Yeah. Any questions?
I just go to your homepage on the web.
Yeah. There will be links on our website's homepage to go find this stuff. So, any more questions?
So I have to ask very carefully. So where do you fit in here? Do you guys have some network behind this?
Yeah. So PubNub is a provider of real-time network solutions, and we've been doing this for the past 4 years, but without any of the WebRTC technology. So we've built this in browser, much like WebSockets or Ajax and REST. You know, we've used technologies that are common today to build a network in which you can have all your devices connected together. So you can actually publish messages back and forth. You can multiplex them to 10,000 devices, 100,000 devices. And so our added value for WebRTC is we can be the signaling channel for that. So we have a global presence network. Anyone who's integrated with the network, you can see if they're online or offline, and you can send them all the information to say, hey, here's how you make a connection to me, in the browser.
So that's the signaling piece. What about the actual sending of the file? If there's no direct, like if you're behind a firewall and you need a turn server, you get involved there? Or?
Not really. We feel like there's a lot of great turn server providers out there today. Yeah, so we kind of let our customers figure out, what the best turn server provider for them is. Any other questions? One in the back.
Yeah, you must have done some internal measurements of performance improvements with
Yeah, I don't have any numbers offhand to talk to, and it changes every day. So they're constantly working on this in the browser every day. So the performance benchmarks haven't quite settled down yet. But what you can generally see is, I can probably send a file. I can send that image that I transferred in a second over an RTC connection, where it might take 10 seconds or 15 seconds if I had to upload it to a server and then download it. So and it depends on the situation too. So if you're doing a game, you're obviously going to see a lot of improvements. If you're doing text-based chatting, might be a little bit less improvement because the packet sizes are smaller. So it really, really depends on what you're trying to do.
What's the max size of the cloud you can actually set?
So that's actually determined by the description protocol that you send, that your browser creates for you. So each browser is a little bit different. The Chrome browser actually limited it to, I think, 8 megs recently. But that's because they didn't feel the technology. They didn't want to flood the internet with a bunch of turn servers and all of a sudden WebRTC connections making 5 gigabyte transfers over a turn server. But essentially, it's whatever you want. It's kind of up to your browser to decide what it can accept, and you can actually change that in the browser. So you get basically a string that tells you everything that you are willing to do, a session description protocol that tells you everything you're willing to do in a peer connection. And so you can actually change those values. Another question over there?
Yeah. Did I hear you correctly say that PubNub is working on a WebRTC framework? You guys and all of the
yeah, so we actually have an open source project at github.com/pubnub/WebRTC. And that is basically a JavaScript framework that makes it a lot simpler to make a WebRTC connection. And you can actually make it without having any sort of signaling server in place today. We leave it up to the consumer to deal with stun servers and turn servers. And those are basically servers that allow you to traverse network firewalls when creating a peer connection. So we don't really deal in that space, but as far as signaling goes, telling when users are online, we've developed the framework. Anyone can download it today, use it today. We have some people already trying it out, and it'll make it a lot easier for you to jump into WebRTC and start using it today. Any other questions?
WebRTC also one of the contributions for OpenStack.
I don't believe so. I don't know the answer.
It's listed on OpenStack track, so it's fine.
Oh, okay.
Not really.
I think that's a property of this track has both kinds of talk on it. WebRTC as a technology is quite distinct from OpenStack as a technology.
Well, it looks so different.
Yeah, so they're completely different technologies, but there will be sessions on both in this particular book.
Oh,
The common denominator is in the book.
All right, one more question. I think we're...
You started seeing startup companies creating businesses around this technology?
Yeah. So there's actually, in the Expo Hall, there's a whole row of companies that have already started to kind of spring up businesses around this technology. I think the main thing right now is that it doesn't work in all the browsers, so people are a little hesitant to it, but we should see that come around in the next 6 months to a year, and that'll really start opening up the field for more companies to to provide value on top of these services.
Can I respond maybe? I have a company called telephone.com that's doing like Skype, an alternative to Skype in the web browser using WebRTC. And I'm talking tomorrow at 8:15 in the morning about business models around WebRTC, and a lot of the companies building.
What's the name of the company?
That's well.
All right, well,
And just to reinforce,
thanks for listening. I'll be around after to answer some more questions. I think we're pretty much out of time, but
this is an awesome number of people in the room. We didn't have this number of people at 8:15 this morning. I'm sure you'll all be back at 8:15 tomorrow morning.
all right, thanks.